Hey guys, welcome to today's Algebra 1 lesson on rate of change of a linear function. We're going to be talking about slope quite a bit in this lesson. I'm sure this is something that most of you have heard of at least, if you're not already familiar with how to do it. But we're going to look at several different types of problems, those involving graphs, tables, functions, and figure out how to find the rate of change given each of those things. So, rate of change is nothing more than how a quantity is changing with respect to the change of another quantity. You're very familiar with all kinds of rates of change, like you hear the term, my car gets 22 miles per gallon, or I make $15 per hour, or the car was traveling 55 miles per hour. There's all kinds of rates of change that we use in everyday life, and you hopefully are familiar with this. So what is rate of change? Again, it's change in one thing. Here it's change in y in comparison to another thing over top of the change in x. So the change in y is the change between the dependent variables over the change between the independent variables. So we're going to find the rate of change given this problem. It says that she's cooking, and we're going to find the rate of the change of the function by using 2 points on the table. So again, remember we said change in y over change in x. So the change in y, we can pick any points that we want. I'm just going to use these two. So if I use those two, I have to use these two. So the change in y, 24 minus 12 over the change in x, 4 minus 2, gives me 12 over 2, which is 6 over 1, which is nothing more than 6, which they wrote it all out over here. I don't really like to, if I'm given a table, I don't sit there and write it out this way. I look at it the way that we did in class. Look what happens from 2 to 4. What did I increase by? 2. What did I increase by to get from 12 to 24? 12. Then I just do it all at once. Well, what's 12 over 2? 12 over 2 is 6. We should probably make sure that it's consistent. Again, they went up 2. From here to here, they went up 12 again. So again, it's 12 over 2, which is 6. So what that tells me is that let me get this off of here for a second. The rate of change is 6 over 1. That means that you can make 6 pancakes for 1 cup of flour. 6 pancakes for 1 cup of flour. Ratios are used all the time in cooking. If you're doubling a recipe or you want to make a huge batch, let's say you're preparing for a large group of people for a Christmas gathering or something, then you would, maybe double the batch twice, which would be the same as quadrupling the batch. So then you have to times every part of the recipe by 4. That's fun. All right, so compare rates of change looking at the student council. It says Jackson High School student council budget varies based on the fundraising of the previous year. So find the rate of change from 2000 to 2005. We're looking at this right here. Oops, let me click on my marker again. We're looking from 2000 to 2005. So what I'm going to do first is I'm going to write down the coordinates of these points. 2000, comma, 1,350. And then the other one was when it was up to 2005, the amount was $1,675. So again, we could set it up the way they did and do the subtraction. I just like to kind of do it in my head. Okay, I know this went up 5. From here to here, I can see they went up 325. So then I put the change in the y, 325, over the change in the x, 325 over 5 is 65. So in that 5 years span of time, the average rate of change was 65. That means that it was growing by $65 each year over that 5-year span of time. So again, we can read that here. I'm sure it says the same thing. This means that the student council's budget increased by $325 over a 5-year period with a rate of change of $65 per year. So then it asks us to do the same thing, but looking from 2010 to 2015. Well, from 2010 to 2015, it went up. Here it's 1550 and here it's 1325. So we can see now that it's going down. They're not gaining as much money. So if we're going to find the change in the X values, that would be the 2015 minus 2010. Now we've got to be very careful and line this up. 2015 was when there was $1,325. So we have to put that above 2015. Above 2010 is when they had the amount of 1,550. So we have to put that above the 2010. This is an ordered pair, this is an ordered pair. And when we subtract, we get a negative value. It tells us that it was decreasing at a rate of $45 per year. Okay, the next one, looking at a constant rate of change. If we're trying to determine, we kind of discussed this already in class when we looked at those released air test questions, but when we were determining whether it was linear or not, we looked to see if it was growing at a constant rate of change, the way that I just showed you in the other problems to look at the table. Look and see what's happening. The x goes down by 3, the y goes up by 2. X goes down by 3, y goes up by 2. X goes down by 3, y goes up by 2. X goes down by 3, y goes up by 2. So my rate of change is the change in y, 2, over the change in x, which was negative 3. So my slope is negative 2/3. It is a constant rate of change, so I know that this is a linear function. Since the rate of change are constant, the function is linear, and the rate of change is negative 2/3. Looking at example number 4. Determine whether the function is linear, and if it is, state the rate of change. So again, we're going to be looking at the table here. So we don't have to flip the flashcard. We could do it ourselves. It's going up by 7, goes up by 7, goes up by 7, goes up by 7. Let's see what's happening here. Looks like it goes up by 3, but then it goes up by 2, then it goes up by 3, then it goes up by 2. So it's not a constant rate of change, because in some places it's going up at a rate of 3/7, in other places it's going up at a rate of 2/7. So we got to be careful for that. That is not linear. It does not have a constant rate of change. Okay, so how does this all relate to slope? Well, the slope of a line is nothing more than the rate of change. The slope of this line is the change, again, in the y values divided by the change in the x values. So slope of a non-vertical line is the ratio of the rise. Rise, think of going up and down as rising. Running is going left to right, so it's rise over run. Change in y over change in x. It's all of those things mean the same thing. So if we have a positive slope, I always show my students a video, and I'll attach it in Google Classroom, or you could just go and search it, puff, puff, positive, and nice, negative, and then it says, I'm trying to think what it says when he goes off the vertical drop off, but it's this video of this guy skiing. So think about it. If you're skiing and you are traveling, let me draw you a little visual here. You're traveling up the hill. It says puff, puff, positive, puff, puff, positive. If you're going up this to go skiing, you're huffing and a puffing and a huffing and a puffing as you climb up this hill, right? You're pulling yourself up. But then when you get up to the top and you get to ski down, you say, nice, negative, nice, negative, nice, negative. And then as you travel along the horizontal line, you're just walking. This is zero fun. He says, this is zero fun. And then he drops off the edge of a cliff and he says, Undefined. Because the slope of a vertical line is undefined. The slope of a horizontal line, there's no steepness here, so it's 0. This has a positive slope, and this has a negative slope. So again, puff, puff, positive. Envision going up this hill. You're a huffing and a puffing, huff, puff, positive. But it's still fun because you know you're about to go down that hill. So puff, puff, positive, puff, puff, positive. You get to the top and you go, nice, negative, as you go skiing down the slope. Then you've got to walk. Oh, this is 0 fun. Trudging along. And then you fall off the edge of a cliff and you're, undefined. A little bit crazy, but anyway, you should totally look up the video. It's probably a little more entertaining than me doing it. So again, that just kind of gives you a little visual for the different types of slopes of line, and we're going to look at this algebraically. So the way that we can find it algebraically, I know if I'm thinking of my little skier, this is a puff, puff, positive, puff, puff, positive. So this has a positive slope, but we can check that algebraically by looking at the change in the y values. So I'm going to do 7 take away 4. Over top of the change in the y values. Since I put 7 or x values, Since I put 7 first, I'm going to put y first. Y minus a negative 3. Okay, so what is 7 take away 4? 7 take away 4 is 3. What is minus a negative the same as? Minus a negative becomes a positive. 1 plus 3 is 4, so the slope of my line is 3/4. Another way we can look at this is we rise 3, we run 4, so my slope is 3/4. Okay, negative slope. Again, imagine the skier. He's just puffed his way up to the top of this hill, going puff, puff, positive, and now he is about to ski down. He's going to say, nice, negative, nice, negative. So again, looking at the x and y coordinates, if we want to look at that algebraically, we can say, okay, change in y, 3 minus 1, that's this 3 minus this 1, over the change in x. So if I'm looking at my change in x, my x values are the negative 1 and 4. So negative 1 take away 4. Again, I line my ordered pairs up vertically. So 3 take away 1 is 2. A negative 1 take away 4. You can think of this as negative 1 plus negative 4. They're the same sign, so I add and keep that sign, so it's negative 5. So when I look at this as a whole, I don't necessarily say 2 over negative 5. It could be negative 2 over positive 5, or we just think of it as a whole. It's a negative 2/5. Negative 2/5 is my slope. So we go down, negative, nice, negative. It's fun to go down the slope, right? That's a whole lot more enjoyable than going up the slope. So nice, negative, he's going down. Okay, looking at our next example, think of the slope of a horizontal line. Again, the slope of a horizontal line, if you're walking along this with your skis, there's no hope of going down a hill. You're going to think, ugh, this is 0 fun as I'm trudging along. The other thing to think about is, remember, slope measures the steepness of a line. Does this line have any steepness at all? No. It has 0 steepness, and we can prove algebraically that the slope of a horizontal line is 0 by looking at the coordinates of the points. Okay, so let's just think about it this way. How much did I rise? Rise over run. I rise 0 units to get from here to here, and I go over, how many did I go over? 1, 2, 3, 4, 5, 6. I went over 6 units. So 0 divided by 6 is 0. You can plug in the numbers if you want to and do the negative 5 minus negative 5. You're adding opposites, so that's 0 over a positive 6. Again, you get 0. So the steepness here is 0. So rather than even plug it in, I just know in my mind, I'm measuring the steepness when I'm measuring the slope of a line, and there is no steepness to this function. So it is not going to have a slope of anything other than 0. The next type of line that we want to look at is the slope of a vertical line. Remember I said when the guy falls off the cliff, he screams, undefined, because the slope of a vertical line is undefined. You guys all know that if you type into a calculator something divided by 0, some number divided by 0, what happens on your calculator? You get this error message, says divide by 0, error. We cannot divide by 0. Now remember, to find the slope, we're looking for the change in the y values over the change in the x values. Think about my x's. We're not changing. My x here is -3. My x here is -3. So there is no change in the x value. The y value changed by 6 units. To get from here up to here, there was a change of 6, but the bottom changed by 0. Try to divide that. I get an error message because we cannot divide by 0. So the slope of a vertical line is undefined. Again, think of the guy going off the cliff. That's not fun. From skiing off the end of the cliff. It says undefined as he's falling down. You're probably getting sick of this, but maybe you'll remember it this way if I keep going over it. All right, and our next one says find the coordinates given the slope. So this time we know that we have one of the values here. We have -4, 5. Our line passes through that, and it passes through another point, 4, R. We don't know what that y value is. So it wants us to find it knowing that the slope of the line is 3/4. So one thing that you could do, you could draw a graph if you wanted and plot -4/5, and then you travel up 3/4, up 3/4 until you get to a +4 on the x value and see what the corresponding y is. That's one way to do it. Or we can just simply do it algebraically. We know the formula for finding the slope is y minus y over x minus x. So if we plug that in, and we know that what our slope is 3/4. So we set up our equation. 3/4 is equal to r minus 5 over 4 minus -4. Well, we can simplify the bottom pretty easily. Now we have a proportions problem. Remember the previous chapter, well, it was a couple modules ago, we did the whole big thing on proportions. We know that we can cross multiply proportions. So we have, that's really hard to see. Let me delete that. We have 8 times 3, which is 24, equal to 4 times r minus 5. We've got to times it by everything over there. So we're going to end up having to apply the distributive property. So we get 4r minus 20 equals 24. Add 20 to both sides, and I get 44 equals 4r. I keep hitting that button, sorry. Divide both sides by 4, and clearly we can see that r equals 11. So the coordinates of this point are 4, 11. I can click through here and show you. They went ahead and multiplied both sides by 8. I set it up as a proportion. Doesn't matter which way you do it. Either way you go, you're going to get the exact same thing of 11 equals r. See, they just multiplied both sides by 8 instead of doing cross products. It doesn't matter. You can do it either way. 3/4 of 8 is 6, and then you're just left with r minus 5. Add 5, and you get 11. And the last example that I'm going to do in this lesson is using the slope to solve word problems. It says the continental slope is often steep oceanic landmass between the continental shelf and the oceanic crust. Near Cape Hatteras, North Carolina, the continental slope is especially steep. If you got your kids out there swimming, you're going to want to be very careful because look, it's like swimming along. You can touch the bottom, and then boom, huge drop. It says the continental slope is especially steep, 75 meters from the shoreline, so 75 meters out. The continental shelf is 65 meters below the ocean surface. That's still pretty deep. Probably not going to let your kid be swimming out that far anyway, but that's okay. At 125 meters from the shoreline, the ocean is 2,700 meters deep. Whoo, that's deep. What is the slope of the continental What is the slope of the continental slope? What is the slope of this drop-off is what it's asking, at Cape Hatteras. So again, we're just going to plug in our points. The y-coordinate minus the other y-coordinate. So we're going to end up adding. But it's still going to be a negative value because look how big that number is. Negative 2,700 plus 65 is negative 2,635. 125 subtract 75 is 50. So when you divide that out, you get that the slope of this line is 52.7, negative 52.7. So what that means is it is dropping, this was in meters, right? It's dropping 52.7 meters at a time. Like as you go out 1 meter, it drops 52 meters. Go out a meter, it drops 52 meters. That is a lot. That's a huge, huge drop. All right, so that finishes up this lesson. Sorry that my light went out again, as usual. But anyway, that finishes up. If you have any questions, please make sure to email me and let me know. Have a great day, guys.